after the data has been inspected, you should have a good understanding of the shape of the data that you are dealing with and any data quality issues the data may have. So we can move on to the data preparation phase of the data wrangling stage. There are a couple of common data preparation steps that we perform in this phase. One is to handle missing values, and the other is to subset the data set into a number of smaller data sets. Let's first talk about how to handle missing values. Missing values can be very problematic in analytics because they can significantly reduce the amount of usable data in your data set, because most analytic techniques will require you to have complete cases in order to perform the analysis. So just to give you an example, so let's say we have a data set with 20 variables. If 5% of the values in the data set spread randomly across the observations and the variables are missing, so which means that for every variable, there's likely 5% of the values missing. Okay. So how much data is actually usable? In other words, how many complete cases do we have in this data set? If you do the calculation, you will find out that only 35.85% of the observations are likely to have complete cases. So as you can see, if you only have 5% of the values missing, it actually can reduce your usable size of the data set by almost 60%. So that's a huge drop in the amount of data you can use for your analysis due to missing values. So that's why handling missing values is very important in analytics. So the first step in handling missing values is to understand why they are missing, because the answer to this question can reveal a lot of the underlying data issues you may have, and also give you some insights about how to handle the missing values. So there are a number of reasons why the values may be missing. For example, the respondents may decline to provide the information because what you are asking is a little too sensitive. So in this case, the missing values are usually not distributed randomly across observations, but tend to concentrate within one or more subgroups. Another common reason why some of the values are missing may be that items do not apply to every respondent. So for example, if you ask employees about their retirement date, some of the employees probably have no planned retirement date yet, so this item would not apply to these people. And in addition, there are also other reasons, for example, human errors, sloppy data collection, and equipment failures that can also lead to missing values in the data set. There are usually two common strategies for handling missing values. First one is called omission. And omission is also often referred to as the complete case analysis. If you use this strategy, you will exclude all the cases with missing values. In other words, you will only use the complete cases for your analysis. So this technique is only appropriate when the number of missing values is small, or they are concentrated in a small number of observations, so that you can simply delete these observations. But also, as you can see, if the number of missing values are large, or they are spread across a wide range of observations, then using omission can lead to significant reduction in usable data sets. The second common strategy for handling missing value is called imputation. Imputation refers to replacing the missing values with some reasonable imputed values. The most common imputation strategy is called the simple mean imputation. As the name suggests, you are going to use the average or the mean of the value to impute the missing values. So for example, if some of the income values are missing from the data set, what we can do is we can calculate the average or the mean of all the income values and use these average income values to impute the missing values. Or another more sophisticated way to use simple mean imputation would be to use the average of the values that meet certain criteria. For example, instead of using the average of all the income values to impute the missing values, we are going to use the average of the income for all the female respondents to impute the missing values for female respondents, and use the average income of all the male respondents to impute the missing values for male respondents. Although simple mean imputation is easy to implement, there is an important limitation. When you replace the missing value with the average value, this may distort the relationship between variables. For example, the total square footage of a house tends to have a positive relationship with the value of the house. If a data set contains many missing total square footage values, and these missing values are replaced with the mean total square footage of the rest of the houses in the data set, then the relationship between total square footage and house value will likely to be distorted. So sometimes, in order to preserve these relationships between the variables, we may use more sophisticated types of imputation techniques. And when a variable is a categorical variable, such as gender, level of education, instead of using the simple mean imputation, we can use the mode imputation, which uses the most frequent category as the value to impute the missing value. Now let's look at an example to see how missing values can be handled in Analytic Solver and R. If you look at this table in the slide, we have a data set from a local restaurant that has conducted a survey to gauge customers' perception about the eatery. Each customer rated the restaurant on its ambience, cleanness, service, and food using a scale of 1 to 7, 1 being the lowest and 7 being the highest. There are some missing values here, as you can see from this table. So let's look at how we can use Analytic Solver and R to handle the missing values in this case. Okay, here I have the restaurant reviews dataset open in Excel. As you can see, there are a few missing values in the dataset. So first, I want to find out which values are missing. And in Excel, there is a pretty easy way to find that out using the conditional formatting technique. The first thing I will do is I'll first select the range of the data from B2 to the end of the worksheet, which is E151. And I go to Home, Conditional Formatting, select the new rule, and select Format only cells that contain as the rule type, and select blank as the rule description, and then click on Format button and select the Fill tab and click on the red so that it will fill the cells with missing values with the red color. Click OK and click OK again. Now it shows in my worksheet the missing value cells because they are highlighted in red. If I want to find out the number of missing values in my worksheet, I can use the formula count blank. So I'm going to create a new column here. I'm going to give the heading number of missing values as the heading for this column. So in this column, I'm going to put in the formula equal to count blank, and I'm going to select the range B2 to E2. Press enter. As you can see, for the first record, there's no missing value. When I copy this formula to the rest of the records, for some of these records, I'll see that there are missing values for these records. If I want to get a total number of missing values, all I need to do is sum up the number of missing values and it shows me that there are 6 missing values in total. And if you want to know how many missing values each variable has, what we can do is we can use the same function count blank equal count blank, and then select the range for each variable. So as you can see, for the first variable, ambience, there is 1 missing value, and I can copy this formula to the rest of the variables, and it shows that for the second variable, cleanness, there is 1 missing value. For service, there is 3 missing values, and there is 1 missing value for food. In Analytics Solver, there is an easy way to handle these missing values. So let's go to Analytics Solver by clicking on the Data Mining menu. We will select Transform and the Data Analysis tab, and click on the option Missing Data Handling. So the first thing you will do to handle missing data is to select a range with at least 1 data row, as suggested by the dialog box. So for the data range, I'm going to click on this button and then select the data range B1 through E151. Click OK. And make sure that you check the box next to variable names in the first row, because the first row contains the variable name. Let's select the variables where there are missing values. So we're going to select ambience, and then hold down the control button on your keyboard and select cleanness, service, and food. Let's select a treatment method. Let's use the delete record, which is the omission strategy, and click on Apply to selected variables, then click OK. Analytics Solver creates a new worksheet. As you can see, now the records with missing values have been deleted. In the transformed data, record number 2 has been deleted because there is missing value in this record. And if you look at the summary data, as you can see, we started with 150 records and we ended up with 145 records, and 5 records were deleted because they contain missing values. Now let's go back to the restaurant reviews dataset and see how we can implement the imputation technique. Again, go to Data Mining, Transform, Missing Data Handling. For the data range, we're going to use the same data range, which is B1 to E151, and make sure that the checkbox next to variable names in the first row is checked. And let's select the variables by pressing down the Control button on your keyboard. This time, to select the treatment method, we're going to select the mean imputation. Click on Apply to select the variables and click OK. Now, Analytics Solver has created another worksheet with the transformed data. If you look at the summary here, we started with 150 records and we ended up with 150 records. Some of these records were treated. One record was treated because there is missing value for ambience, and one record was treated because there is missing value for cleanness, and so on. And if you look at the transformed data, all records are there. If you look at record number 2, where there is a missing value for the service variable, the value is 5.96598, and so on. This is the average of the service ratings in the dataset. So as you can see, Analytics Solver has replaced all the missing values with the mean of the data. Now let's look at how we can handle missing values in R. We're going to use the same example as before, restaurant reviews dataset. First, in RStudio, I'm going to import the restaurant reviews dataset into a data frame and label it My Data. I'm going to click on Import Dataset from Excel and then select my data file. Which is chapter 2 underscore data. It is an Excel file with many worksheets. And I'm going to select the worksheet, Restaurant Reviews, and then label this new worksheet as My Data. And click on Import. As you can see from this data set, there are some missing values. For example, the service rating for record number 2 is missing, and the cleanness rating for record number 13 is missing. Both of them have the value NA, which means missing value in R. So I'm going to return to my empty script, and in R there is a function called is.na, which will tell you which value is missing in your dataset. For example, if I type in is.na parentheses with the name of my data frame, my data, it will show me all the values that are missing in that dataset. If I run this script, as you can see, it will show me that which value is missing in the 150 records I have in the dataset. The missing value is shown as a true because it returns true if the value is missing to this function, and it returns false if the value is not missing. If you only want to see which value is missing for a certain column or variable, what you can do is using the is.na function only on that column or variable. For example, if I want to see how many
values are missing in the service variable, I can type in is.na my data $ to get to the variables and select service. If I run this, the result will show me that there are a couple of missing values in the service variable. For example, this one shows it's missing, and this one also shows it's missing. However, if you have a very large data set, using the is.na function to detect the missing values can be pretty difficult because it's going to fill up the entire screen. So alternatively, what we can do is we can use a function called complete.cases to identify the rows in the data frame that are complete. So for example, if I type in my data square bracket complete.cases function of using my data as the parameter for this function, and a comma, and then leave column number empty, which means I'm going to retrieve all the columns. If I run this line of code, okay, as you can see, it's going to show me all the cases that are complete. In this case, it's producing a 145 by 5 matrix for me for the data, which means 145 cases are complete out of the 150 cases we have in the data set. However, by using this instruction, it doesn't show me which cases or records have missing values. If I use a variation of this function, I will be able to find out which records have missing values. So what I can do is my data square bracket, and then use the exclamation sign, which is the not operator in R, in front of the complete.cases function. And if I run this script, this time it's only going to show me the records that have missing values. So as you can see, records number 2, 13, 26, 100, and 134 all have missing values. Okay, now that we know that there are missing values in this data set and which records have missing values, we can implement one of the two strategies that we discussed earlier to handle missing values, omission and imputation. First, let's talk about the omission strategy. In R, there is a function called na.omit that will allow us to remove observations with missing values. So let's do this. We are going to create a new data frame called omission data, and I'm going to use the na.omit function on my data frame to remove all the records that have missing values. If I run this command, and then let's use the command view omission data. As you can see that now the data set contains 145 records, and all of them are complete cases. Now let's talk about the imputation strategy. To implement the simple main imputation strategy, we will start with the original data frame my data, and then try to calculate the average value using the main function in R. And it's also important to add the option na.rm equal to true in the main function, because it will remove all the missing values when calculating the average values. So I'm going to create a new variable called ambiance mean, and I'm going to use the mean function in R to calculate the mean value for the ambiance rating. and make sure that I also include na.rm to remove all the missing values when calculating the mean. And I can do the same thing to create the mean value for the service column. And I'm going to run both of these two commands together. And let's take a look at these values. So if I type in ambience mean and click on run, as you can see, the mean for the ambience rating is 4.42953. And the mean for the service rating is 5.965986. Now we can input the missing values using these mean values. So I'm going to type in my data $ambience square bracket is.na my data $ambience, which is going to retrieve all the values that have missing values and assign the mean of the ambience rating to these missing values. And I can do the same thing for the service column. If I run these two commands together, if I view my data, you will see that there should be no missing value for either the ambience column or the service column. For example, record number 2, originally there was a missing value for the service column, and now it has been replaced by the mean of the service ratings, which is 5.965986. And for the ambience column, there was missing value for record number 134, and now it's being replaced by the mean of the ambience ratings, which is 4.42953. Instead of using the mean to input your data, you can also choose to use median or mode to input your data.